So we are really looking forward to your presentation.
Thank you for the kind introduction. Ladies and gentlemen, I will give the perspective from the technology provider within CCUS and the supplier side. And I will focus on a new type of delivery from us, which is named Justtouch, a modular capture plant. We have been through this earlier today, but we have seen a drastic change after the Paris Agreement in the industry, and they are more concerned about their emissions, and they would like to find a solution for greenhouse gas emissions. And we see also the public are now acting, and the children are engaged. There are school strikes around the world, and they want action from the politicians. And I can understand that. We have been talking about CCS for many years, and if you look very broad on this, very little has happened over the years. And one factor which we have not touched upon, which I think is even more important, is the finance rating. That's very important today, and if your company cannot demonstrate a sustainable business, then it will affect your share price, and people are not interested to invest in your company. So that is a very important driver for companies. And the industry is changing fast. This is a picture from Largescale power station in Scotland. We were the first to test carbon capture in UK back in 2009. And now the coal industry is out in the UK. And it was the first week without any electricity from coal on the BBC now in May. So it's going fast. If you look at the Paris Agreement, how can we meet the Paris Agreement? There are basically three elements: is energy efficiency, more renewable energy, and what we have talked about today, carbon capture and storage is a necessity. In Aker Solutions, we are engaged in all three sectors. We work hard in the oil and gas sector to decarbonize the oil and gas industry and come with good solutions for the oil companies. And subsea compression is such a new product we are offering. Regarding renewable, we are one or two players globally on floating wind, and we are engaged in projects in the US. And Aker Solutions has been engaged in CCUS for many years, which I will come back to. I will focus on the CCUS. This has been covered earlier today. Both Merkel and May have been very clear, and we see now it's an increased interest and support both from the politicians in Europe and from the industry side, which is very important. And maybe these ladies have looked at these curves. These curves shows the emissions in Europe in million tons from different industry sectors, and you can see the figures here from 2016. It's going down, but something drastic must be done. And CCS will be the solution for the main emitters like energy, industry, waste energy, and biomass. We have to take the large emitters, the large sources, and do CCS. And think about the energy sector. If we replace coal, that will help, of course. But if we replace it by gas, we put on half of the CO2 back again. So we need CCS. And if you look at Norway, oil and gas sector is big, so we can obviously do more in the oil and gas sector. If you look at the process industry, there are about 10 million tons of CO2 in the cement and melting industry. And then we have about 2 million tons for the waste energy, which has been covered by Fortum today. So there is a home market also for CCS for the rest of the industry. Aker Solutions, we are engaged in the whole value chain. We are doing carbon capture, we have our own technology, we do liquefaction, we are in the CCU business, we do pipeline transport and liquid CO2, We are engaged in the offshore CO2 separation, like on the Sleipner field. We have subsea equipment for doing CO2 injection on the seabed, like on the Sleipner, and we are also in the CO2 EOR business. So we are covering the whole value chain for CCS. Back to our technology. As you saw the introduction from Niels today, he mentioned the Solvent program, started up in 2008. That is the basis for our technology. It was a large R&D program together with SINTEF and NTNU here in Trondheim with industrial partners. We invested 33 million euro in the program. It went over 8 years. 50 researchers worked on the program. We tested in 6 pilots, and we tested about 90 different cocktails of solvents to find the right mixture. So to summarize our technology today, we have a green solvent we are offering in the market. It's non-toxic, it's biodegradable, it's non-corrosive. We have reduced energy demand by about 35% from standard MEA solutions. And we have a quite unique anti-mist system, which we have tested in Alabama and US, and we offer that as a standard in our technology, which eliminate the emissions of amines to air. So we have very good HSE performance in our technology. And we offer a large-scale plant and these standardized plants, which I will come back to. I would like to highlight the solvent, the importance of solvent. This was the main development in the Solvent R&D program to find the right solvent. And you can look at the standard solutions here. This is from TCM test. We have reduced the degradation by a factor of 10. And this will have a great cost impact. So even if our solvent is a bit more expensive than the standard MEA, if you look at life cycle cost, this is, of course, the best one. And here you can see some sample from Heilbronn. It's a coal-fired power station in Germany. We tested there in a pilot. And you can obviously see that MEA is not a good option for carbon capture. So we need something else, which we now can offer by our S26. We have tested carbon capture since 2008 in our mobile test unit. We have tested on fossil fuel. We have tested at a cement factory with Norcem, and we have tested for 1 year with the same solvent at Clemenceau. So we have learned quite a lot, and we can now offer a full-scale plant for these industries. We did the design and we delivered the amine plant at Technology Center Mongstad. This has been a success. We tested there for the first 2 years, and we are ready for large-scale, commercial-scale plants after these tests. And several companies have tested after us at Mongstad, and this has really been good for Norway to really offer this as a big laboratory for carbon capture. Today we offer 2 different plants. One we call Justtouch, which is a small to medium-sized capture plant, standardized. And the other one is Big Catch, where we do more heat integration and integration with the existing mother plant. You have seen the national demo project previously today by Gassnova and others. And you can see the 2 boxes where we are engaged. We are doing a front-end engineering design for the CO2 injection offshore and the control system for that on behalf of Northern Light. And we are also developing the carbon capture plant for Norcem Heidelberg in Brevik. So I will come back to that. This is showing the test, 18 months test in Brevik. Norcem Heidelberg, they tested 4 different technologies, and based on the test, they selected our technology as the preferred. So we are now finalizing a feed for Norcem Brevik, where we're looking at 400,000 ton carbon capture and liquefaction. And the plan is that this will be in operation in 2023. And I would like to highlight the Norcem process is a very sound project. We have a very good experience with Solvent over 18 months, which takes out a lot of risk. And it's about 20% CO2 in the flue gas, so it's low-hanging fruit. The plant will be more compact, the capture plant. And as you can see also, we have designed 400,000 tons to utilize the waste heat in the flue gas. So it's purpose designed based on the available heat in the flue gas. 2/3 of the CO2 emission from the cement come from the limestone, the process itself. And we have liquefied the CO2 and we can store it in a nearby quay in Brevik. And we have also seawater for cooling, which is the benefit. And if you look globally, the cement contributes about 5% of human CO2 emissions, and we need cement in the future. So it's a good project. Now over to this Justtouch unit, which we developed over the last 2-3 years. It's a standardized unit up to 100,000 ton capture. It's a complete delivery, fully automated. It comprises 3 process containers here, 20 and 40 feet, and this is an electro instrument control room. And these columns, they will be delivered directly to site. The process containers here will be prefabricated and brought into the site. And we can then cut the delivery time down to about 15 months. And of course, this is very compact, so we save a lot of materials. So this is more a kind of procurement and fabrication job. So we don't have to do a lot of engineering. That's why we can have this quick delivery. And imagine if you have been at TCM and looked at the Mongstad plant. We can now bring in the TCM plant on 2 trucks, lift off 4 containers and hook up for a month, and then you have a complete carbon capture plant capturing 100,000 tons. So it's very efficient, and it had a lot of benefits. I can't go through everything, but it's a new kind of product in the market, and we have sold the first plant in the Netherlands, which I will come back to. So this is just to compare the Mongstad plant with Justtouch. You can see that it's 2 different plants. Extensive bulk materials, of course, at Mongstad. It's not fair to just compare like this because Mongstad is a special plant. It's not a commercial plant. It's a test facility. But it gives you some idea of the compactness we have achieved. And the Mongstad, when you have a development project with engineering, it's about 32 months, and now we are down in 15. This is a helicopter view of Mongstad, so you can see all the savings on the materials. We have seen also the increased interest from industry, and part of the picture, as mentioned by Stephen, is this increase in cost of emissions. We are now up at around €25. This curve, I think, is interesting. I mentioned TCM, and if you build carbon capture based on oil and gas standards, we are up here on the curve, the cost for euro per ton of CO2. And obviously, this curve is on the way down. So we have reduced the cost by a factor of about 10, but still you can see it's a way to go down to the cost for emission. But what we see is that some of these CCU projects, like in Twence, which I will come back to, is actually going ahead. And that reason is that the government gives some support, and of course they can sell the CO2 for the user, which will then close the gap. And if we shall go further for including transport and storage, of course it will be more costly. But this is for small and medium-sized sources, which can then use the CO2. These will be large volumes, and CCS is the only solution for that. So I think this CCU business is very important. And And there is a lot of industries coming up, as you can see on the bottom of this slide. A lot of research and industry are now looking in to use CO2 as a kind of feedstock for other products. Some of these are good also from an environmental point of view, and some have a minor climate effect. This is the project I mentioned. This is the first sale from us on a complete carbon capture plant to a waste-to-energy plant in Holland. The client is called Twence, is in the eastern part of Holland. We will deliver 100,000 ton capture and liquefaction, which will then be distributed to greenhouse. And in these greenhouses, this gas, which is partly bio, will replace fossil fuel in these greenhouses. So it has a positive climate effect. And this is a good example on CCU, and I think you will see more of these projects which will come in the near future. And the project and the plant will be in operation in 2021. And we will deliver food-grade quality, so it's also this flexibility. You can sell the CO2 to Heineken or whatever. It's the flexibility. This shows the plant. Here you see the Justtouch unit with the Twence plant in behind here. The CO2 comes, the flue gas comes here. We capture the CO2 and we bring the treated flue gas back into the chimney. So there are no new emitting points at Twence. The pure CO2, 99.9% from the Justtouch is going here, and then it will be liquefied. And here you see the storage tank for liquefied CO2, which will then be distributed to greenhouses. So to conclude my presentation, I think it's now crucial that the national demo project in Norway will go ahead and that it will be sanctioned by the government by 2020. We have been waiting very long for this, and now it's the time. And it's also important that similar projects come in Europe. We have mentioned France, Germany, we had Holland, UK. There are many sites, storage sites under development, so it's important to also get going on these. And this is very important. Available CO2 storage sites will open the CCS market. We see that the industry now is on hold. They are waiting for a site where they can deliver the CO2. And another important factor is that authorities should also support CCU. That will be the early mover. And we see that in Europe, and we are a bit behind in Norway, so I hope that will change in Norway. Most of the CCU plant will have a positive climate effect and will be part of this growing circular economy, which is important for the industry and workers. And I would say that the deployment of CCS and CCU towards 2050 will be crucial for the emitting industry. And as a kind of slogan for the industry, this is really the license to operate. So with that, I will say just get going, just catch it. Thank you.
Thank you. We have time for one important question, and I will not be surprised if it's about CCU.
Understood.
Understood.
Good.
Okay, just we had one common question.
Hi there, Jonathan Lee from Newcastle University in the UK. I have the question about CCU. You're delaying your emissions by putting it through the greenhouses, so what is the delay in emissions? I mean, I get that it's a use for carbon, but you're only delaying its emission to atmosphere. It goes into plants and then it goes into the atmosphere.
Yeah, it's part of your question is correct, but if you look at the Twence project, 50% of the CO2 we capture is from bio, which are replacing fossil fuel CO2.
Okay. Mm-hmm.
I think I'll stop that discussion there, and thank you, Oskar.
Thank you.